Today we will see sinusoidal waves. So in physics, sinusoidal waves are represented mathematically by f of z comma t, which is equal to a cos of k in bracket z minus vt plus delta, where a is called as amplitude of the sinusoidal wave and the argument of the cos theta cos function is called as phase, where this delta is called as phase constant. If we try to see this sinusoidal wave graphically, so here we can see on x-axis we have z direction of propagation, where in this case it is z-axis and positive z-axis, and y-axis is the amplitude of the wave. So if we look carefully, here k is the 2 pi by lambda, which is called as wave number. So wave has one central maxima and the phase difference, okay, so central maxima will be maximum whenever this phase is equal to 0. If we equate this phase equal to 0 at time t is equal to 0, so we will get z is equal to delta by k. So the wave is lagging behind by delta by k amount, so that is shown here. Now if we try to see more formulas, so the time of propagation of wave is given by distance upon speed or velocity, which is equal to, so distance here will be one wavelength, so lambda, and the speed or velocity is v. So 2 pi by k is your wavelength. We can get it from this equation, and thus we get time is equal to 2 pi upon kv. So if you want to calculate the frequency, it is 1 upon time, so which is equal to kv upon 2 pi, which is equal to v upon lambda, because lambda is equal to 2 pi by k, again from this equation over here, because from this equation lambda is equal to 2 pi by k. So that is frequency is equal to velocity upon wavelength. Then if we talk about angular frequency, that is equal to 2 pi mu, so which is equal to 2 pi into mu. So mu value we will take it from the frequency value, that is kv upon 2 pi. So 2 pi will get cancelled and we will get angular frequency as kv. K is the wave number and v is the velocity. So f of z comma t, it can be written, the wave equation can be written as a cos of kz minus omega t plus delta. So this is the wave traveling in the positive z direction with amplitude a and phase constant delta. We can have a wave traveling in the negative z-axis as well. So in order to have that negative wave traveling along the negative z-axis, this is the wave traveling in the negative z-axis, that is shown by these two equations. Because cos function is even function, so we can replace this entire theta by minus theta, so that is minus kz minus omega plus delta. So that is also one of the notation by which we can show the wave traveling along the negative z-axis. So there are complex notations as well. So first of all we will use the Euler's formula. So e raised to I theta is equal to cos theta plus I sin theta. So this gives us a much more simpler way to represent the waves. So we can show that f of z comma t, which is equal to real part of a e raised to I kz minus omega t plus delta. This is the wave traveling along the positive z. F tilde z comma t is equal to, which is equal to a tilde e raised to I kz minus omega t, which is a complex wave function. A tilde is equal to a e raised to I theta. So we have observed the wave phase constant in the amplitude, Actual wave function is real part of f delta, so which is this. Now complex notations, why we are using this? Because complex notations are much easier to handle, as exponentials are much easier for the calculations.